Hi guys. So I've started the Colin problem, the building of the deck. So we've got a deck. It looks something like this. And we have one dimension, we can call that X. And then the other side length has to be 10 more than that. And so then we get this figure. We've got to create an equation from that. Remember, area equals length times width. And so that's how we get this equation. This is, now if this was equal to 0, I could set both of these parentheses equal to 0, and then I get my answer. But it's not. So we've got to distribute this out. We've got to solve this, see if we can get it to equal to 0 and factor it out. And if we can't, we now have some other methods from this lesson that we can use. So I've done some of that work, and unfortunately, it doesn't look like something I can factor. Now you might say, okay, well, how does she know? Well, you use your box method. You see if you can get something that multiplies to negative 160 and adds to 10. That's not really going to work. The good news is what I'm about to do is the method I'm about to use is even if this could have been factored, completing the square will still get you the right answer. It's not like it'll be wrong. Whereas if it can't be factored, you can't move forward with factoring. Okay, so if I look at this, what I'm going to do is I'm actually going to move the 160 back. And then I'm left with x squared plus 10x. I'm going to leave that blank equals, sorry about that, equals 160 plus something. Remember, these are those blanks. We don't know what those numbers are going to be. That's part of the completing the square piece because we want to get this side to be one of those perfect squares. So what I'm going to do is I'm going to do my little thought bubble, and I'm going to think about, I take this middle term, 10, I divide it by 2, and then I square that. 10 divided by 2 is 5, and 5 squared equals 25. So to keep my equation balanced, if I'm going to add it to this side, I also have to add it to this side. So plus 25 and plus 25 over here. Then I end up getting x squared plus 10x plus 25 equals 185. Okay. And so the whole goal is not now to move this back. That was not the whole point of this. Instead, we're going to look at this side, and what should have happened is this should be the same two parentheses. So another way to think of it is this times this, and what's in here should be the same. So if I think of two numbers that multiply to 25 and add to 10, it's 5 and 5. So we'll get x plus 5 here. And another way to write that is with the squared, because what's inside the parentheses is the same thing. And then I bring down my 185. Now this is vertex form. And so this is what you were working on last class. So now I'm going to solve for x, and I get x plus 5 equals, because I square rooted this, it's plus or minus the square root of 185. Now that's not a perfect square. And so what I'm going to do is I'm going to figure, I can either simplify that to keep it exact, or if I was really building a deck, I would want to know what the dimensions were, and a decimal would be okay. So if I get my calculator out and I take the square root of 185, I end up getting, still plus or minus, I'm going to round to my nearest tenth, 13.6. And then I've got x plus 5. I'm going to subtract 5 from both sides. And then when I do that, what I end up getting from this is two answers. My first answer is positive 13.6 minus 5. And my second answer is going to be negative 13.6 minus 5. Okay, so if I figure both of those out, I end up getting, I'm just going to do it because I'm taking a video and I don't want to mess up, I get 8.6. And then if I subtract this, I already see that this is going to be a negative number. And because this is a real world problem, not just a completing the square kind of random problem, this is not going to give me an answer that's going to work for a dimension. So I can go ahead and just stop there. Okay. So this doesn't mean my answer is 8.6, because if we think back to Colin's problem, the problem was, what are the dimensions? So the dimensions, if we go back up here, well, the dimensions turn out to be approximately 8.6. And then don't forget, this one was 8.6 plus 10. And what that ends up giving us is 18.6. So a way to write our dimensions out are 8.6 by 18.6 feet. And then that is our answer. Sorry, I got a little low. There you go. Hope that helps, guys.